Hello Year 11, welcome to our 6th video here for our 10th topic. We're looking at area today and we're going to start off with units of area. Now most of these we're going to use square units, right? The square of our linear units. So we're going to talk about square centimetres, square kilometres, square millimetres and so on. When I convert from, let's say, centimetres to a metre, I know that I need to divide the number of centimetres by 100. There's 100 centimetres in a metre. Now, when I convert from square centimetres to square metres, I have to apply that same conversion twice. So I divide my square centimetres by 100 and then divide by 100 a second time because it is a square. We've got to essentially divide by the length and by the breadth. So however many linear units, we use that again for our conversion, right? 10 millimetres in a centimetre, 100 centimetres in a metre, 1,000 millimetres in a metre, 1,000 metres in a kilometre, right? We use those conversions, but we use it twice. I would generally recommend, though, rather than doing a unit conversion, that you just use the output units at the beginning. So if you're asked to provide an answer in square metres, then perform your area calculations using dimensions in meters to begin with. Mostly makes life easier. Now, there is another quite common and very valid unit of area that we will use, and that's the hectare. Now, 1 hectare is equivalent to a square that's 100 meters on each side. So 1 football field is about 2/3. If we just talk about the playing area, a little over 2/3 of 1 hectare. If we went to Hunter Stadium, McDonald Jones, whatever it is in Newcastle these days, there would be very close, I suppose, to 1 hectare of grass inside that field, including the areas around the outside of the playing area. So that's 1 hectare. There are 10,000 square metres in a hectare and 100 hectares in a square kilometre. You don't have to perform that conversion twice. That's already built into those figures. So, first of all, we have this example. A sheet of A4 paper is 210 millimetres by 197 millimetres. That's pretty close to the dimensions of a sheet of A4 paper. Calculate its area in square centimetres. There are 2 ways to do this. I would suggest it's the easy way and the hard way, and look, we'll do both because that's just the kind of person that I am. So first of all, let's have a go. We could say our area equals our length times breadth is 210 times 197. I am of course going to need a calculator to do this, so here's one I prepared earlier. So 210, oh actually it's not going to quite fit, this might work. So 210 times 197 equals, now I get 41,370. Square millimetres. Now to convert millimetres to centimetres, we would divide by 10. Here we're going to divide by 10 twice, divide by 100. This is 413.70. Right, the 0 is actually a significant figure there. 413.70 square centimetres. Right, that's one way to do it, using the conversion divide by 10 twice. Now, alternatively, we could convert these figures. Right, that's option 1. Alternatively, we could convert them to centimetres in the first place. Okay, so I'm going to say my area equals, so that's 21 times 19.7 centimetres. Okay, and that's going to, oh, here we go. Now 21 times 19.7 equals, right, 413.7. square centimeters. Either of those works fine. I would typically convert to centimeters at the beginning, not convert my square centimeters. Now, how many hectares are in 1 square kilometer? It's listed here as an example. I would just remember that figure and say that there are 100 hectares. HA is the abbreviation, is 1 square kilometer. Okay, you could think of these squares that are 100 meters on each side. If I lay 10 of those squares together, I would get a strip that's 1 kilometer by 100 meters, so I'd need 10 of those strips. So 10 times 10 is 100 to cover a 1 kilometer square. Convert this many square centimeters to square millimeters. Okay, so centimeters to millimeters, we normally multiply by 10. Millimeters is a smaller unit, so I need a bigger answer, so I'll multiply. But instead of multiplying by 10, I've got to do that twice because they're square units. So I'm going to say 1,670 square centimeters. Going to put 2 more zeros on the end, right? Which is going to be, is that right? 167,000. Oh yeah. Square millimeters. Okay, we multiplied it by 10 and then by 10 again, puts 2 zeros on the end. There are a bunch of areas here. This can be a big exercise and I hope the video doesn't get out of control here. Most of these things you should know. I haven't sketched these figures, but I'm hoping you remember the properties of them. Look them up if you need. Rectangle length times breadth, we certainly use that a very great deal. And a triangle, half the base times the perpendicular height. Half the base times the height is very important as well. Parallelogram, not too much, base times the height. But trapezium. Now, my way, my personal understanding, the way that I like to think of the area of a trapezium is I average out the parallel sides. That is, I add the lengths of the parallel sides together and divide by 2, and multiply that by the distance between them. Okay, so that's sometimes written as h over 2 outside of a plus b, or sometimes it's written as a plus b over 2 times h. Whichever way that's written, that's the same sort of idea. The average of the parallel sides multiplied by the distance between them is quite important. A kite we won't see very frequently, but one way of doing it is half times the product of the diagonals. Now you could always, if you have the lengths of the diagonals, you will see that you could quite simply divide that kite into some triangles, and using half the base times the height and adding those triangles together, you'll get the same result. Area of a circle is important, pi r squared, and the area of a sector, now we had looked at an arc length before, which was a fraction of the circumference, and a sector is going to be a fraction of the area, and the same process, theta over 360, right, that central angle between the two radii, divided by 360 gives us our fraction, and multiply that by the area of pi r squared. Righto. Oh, okay, now I don't have an example there. There are stacks and stacks of these for you to do. Sometimes you will need to add areas together, sometimes to subtract one area from another. Draw a good diagram, but don't take too long. Use a pencil. Sketch it neatly, but probably not using a ruler. Dimension it if you need be, particularly where you are calculating new additional dimensions for your diagram. That's particularly important. Do it piece by piece. Use sketches to help explain what you're doing, and don't round off too soon. That's the main advice I'd give there. Okay, as you work through these, you'll very likely come across some curious ones, interesting ones, things that you don't necessarily understand. Okay, those are good questions to ask in class. Make sure that you're doing that. I'll see you there.